Those who are listening on YouTube, please let me know whether you are I'm audible to you or not. I'm audible to you or not. Okay. Now let us start. Very quickly, we will finish trigonometric analysis. Okay. Earlier we have seen different definitions under this and different concepts. So just revise in 5 minutes. We started trigonometric analysis. Okay, and for your syllabus for this semester now, I will teach you paper 302 ka physical chemistry and inorganic chemistry part, paper 303, unit 2 and unit 3. Then we started chemical and trigonometric analysis. The basic is it is under quantitative method of analysis. Then we have seen different definitions of uh, basics of this part: titrometric analysis, titrant, titration, equivalence point, end point, then titration error indicator, conditions suitable for titrometry, types of titration, each type of titration in detail with its example, including example of indicator. This is very important. You have to remember what are different types of titrations, uh, concept of each titration along with which indicators are used, and why you are getting color change. Okay, like for complexometry, your color change is due to free indicator, color of free indicator. Then redox titration we have seen. Each and every minute part I have covered or put on this slide. Okay, so that when you will go through just slides, your revision will be done. In After that, we have seen how select indicators are selected, then concept of standard solutions, their requirement and examples of those, then concept of secondary standard, the highlights of secondary standards, then examples of primary standard. Okay, examples of primary standard, and in different types of titrations, how different primary standards are used. Like for acid base titration, these many are primary standards. So while preparing for examination, you will have to remember examples under acid base titration, examples under precipitation titration, complexometric titration, oxidation reduction, etc. All okay. So uh, remember every example. Like question can be like, which of following is not primary standard used in acid based titration. Okay, so where the word I have used is which of following is not. तो जब not रहेगा तो ये लिस्ट में से नहीं आएगा. सपोज मैंने बाकी सब तीन ये लिस्ट में से डाला और फोर्थ मैंने अनदर लिस्ट में से डाला, तो दैट विल बी ऑड मैन आउट. ओके, तो रीड क्वेश्चन केयरफुली. क्वेश्चन क्या आया है वो आपको केयरफुली रीड करना है. दो आंसर इज वेरी सिंपल. सक्सिनिक एसिड आपको पता रहता है, बोरेक्स पता रहता है, सोडियम कार्बोनेट पता रहता है. अगर मैंने उसमें सोडियम क्लोराइड भी ऐड कर दिया तो सोडियम क्लोराइड इज नॉट प्राइमरी स्टैंडर्ड यूज्ड इन एसिड बेस टाइट्रेशन. ओके, तो दिस टाइप ऑफ क्वेश्चन कैन बी देयर. सो ये वाला पार्ट हुआ था अपना एसिड बेस टाइट्रेशंस. अभी हमने देखे थे how the growth of acid base titration has done, acids and base concept, and then titration curves. So in acid base titrometry there are four different types of titration. Very first is when you have strong combination, strong acid versus strong base. Then in second you have strong acid versus weak base. Then weak acid strong base, and then in last weak base weak acid. Okay, there is one more announcement for all those who are attending on YouTube. I can see 10 are there. So kindly put your name and division. Okay, if you are like Saurabh Pagare, write your name and your subject combination like PC or micro biochem or CBCZ. Okay, those who are attending on YouTube, kindly put your name and your subject combination in chat box of YouTube. Then we have seen that, for example, in strong acid and strong base, what we have seen, when strong acid and strong base combines, they react in stoichiometric quantity, and you can calculate pH at each step. Okay, pH at each step, and steps for calculating pH also we have seen. Okay, just for acid, it is what, if you have monobasic acid, pH of acid is equal to pH of solution. For dibasic, you will have to convert, but for monobasic, pH of acid, like here we have used HCl, so HCl का अगर 0.1 मोलार लिया है तो pH of solution will be negative log to the base 10 of concentration of that HCl. Now, for acid base, we have seen the टाइट्रेशन कर्व. ओके, ये वाला टाइट्रेशन कर्व तक लास्ट टाइम हुआ था. फॉर एसिड बेस्ड टाइट्रेशन, व्हाट इज बेसिकली टाइट्रेशन कर्व? टाइट्रेशन कर्व इज नथिंग बट प्लॉट ऑफ pH against volume of NaOH. So again, remember, in analytical chemistry you have different plots. Okay, different ग्राफ रहेंगे, तो y एक्सिस पे क्या लिया है और x एक्सिस पे क्या लिया है, यू जस्ट रिमेंबर, और वो ग्राफ को क्या बोलते हैं वो रिमेंबर कर रखो. The graph of pH on y-axis and volume of NaOH on x-axis is called as titration curve. Okay, so this is titration curve for acid-base titration, where you can easily see before neutralization point, before equivalence point, your solution is strongly acidic. Okay, and after neutralization point, your solution is this is what, strongly basic part. So this is strong acid versus strong base type of titration. Then again, for other combinations, just remember this strong acid strong base का concept हुआ. Now for weak acid versus strong base, weak acid versus strong base, ये equation याद में रखो. For weak acid versus strong base, pH of solution can be calculated using this equation. Okay, pH of solution can be calculated using equation pH is equal to half of pKw plus half of Ka plus half of log of C. Okay, so you have derivation in detail, but since we are lagging too much, so the derivation part we are skipping. But just remember, for strong acid, strong base versus weak acid. Your acid is weak, like acetic acid is your weak acid. If you are titrating, if you are titrating acetic acid versus NaOH, this type of titration will be the weak acid versus strong base. Your acetic acid is weak acid and NaOH is strong base. Okay, so this type of titration, if it is there, then for that pH of solution will not be directly at equivalence point, pH of solution will not be directly on just negative log to the base 10 of concentration of H plus ion, but here since your acid is weak acid, you will have to consider its degree of dissociation, and also the how much concentration of conjugate base is formed, and that time it will be more strong. So pH is calculated using this equation. And again, remember, in this titration weak acid against strong base, pH at equivalence point is always greater than 7. Okay, जब भी आप स्ट्रॉन्ग बेस अगर टाइट्रेशन में रहेगा, बेस अगर स्ट्रांग है और एसिड अगर वीक रहेगा, तो जो वाला पार्ट स्ट्रांग है वो साइड में पीएच जाएगा. ओके, हियर योर बेस इज स्ट्रांग. ओके, तो बेसिक साइड क्या रहता है, अबव 7. तो देयरफॉर pH at equivalence point is greater than 7. pH at equivalence point is greater than 7, and the half equivalence point, at half equivalence point pH is equal to pKa. Remember all these three sentences carefully. Okay, pH का formula, when it is weak acid versus strong base, everything is positive. Okay, and equivalence point का pH value is greater than 7, and हाफ इक्वेलेंस पॉइंट में पीएच कैसे कैलकुलेट करते हैं, इट इज डायरेक्टली पीकेए वैल्यू. ओके, तो दिस इज अबाउट titration weak acid versus strong base. Now for titration of strong acid versus weak base, tell me example. strong acid का example बताओ. HCl. Okay, HCl is strong acid and it is titration of HCl versus weak base. Example of weak base is ammonium hydroxide, NH4OH is your weak base. Okay, so this type of titration, if you are titrating HCl against ammonia or ammonium hydroxide, most preferably we take. So this titration is strong acid versus weak base. Now for this, pH of solution at equivalence point is calculated using equation pH is equal to 1 half pKw, as same like this. Here pKb value of base is taken. Here it was Ka value. Here it is pKb value minus half log C. Okay, here it was plus. Here it is minus. Just remember this difference. We are not going in details because we don't have time, and also the examination is not offline examination. So just remember the equation for strong acid versus weak base. It is pH is equal to 1 half pKw minus pKb minus 1 half log C. And in this type of titration, the pH at equivalence point is less than 7. Okay, तो strong कौन है example में, acid is strong, so at equivalence point your pH is less than 7, and in titration, and in this titration pH at half equivalence point is pH is equal to pKw minus pKb, pK value of dissociation constant of water minus pKb value, base of that of base. Okay, so this is how the different calculations are done in acid base titration. So strong acid, strong base we have seen in details in previous lecture. For weak acid, strong base, we have uh, pH का equation at equivalence point is pH is equal to half pKw plus half of Ka plus half of log C. pH value is greater than 7, so therefore we can use indicators whose pK indicator is in the range of basic pH range. Okay, तो इधर जो indicators use करते हैं weak acid versus strong base में, since its value is greater, pH at equivalence point is greater than 7, तो indicators ऐसे select करते हैं कि जिनका pK indicator value matches in that region. Okay, basic region में, और इधर जिनका for strong acid versus weak base, the indicators are selected so that they are in lower pH region. This is about acid base titration. So for your syllabus, acid base titration was in detail. Just remember these things. Okay. Then we started gravimetric analysis in last lecture only. Basic concept of gravimetric analysis is it is my quantitative method, that is we are determining amount of substance by weight difference method. So before analysis, how much amount we have taken, and then after analysis, how much amount we got as precipitate or anything after analysis, that we are estimating and amount is determined. So it is gravimetric method of analysis. The regular method that you are using in lab is precipitation gravimetry. Okay, this is precipitation gravimetry. This involves chemical precipitation. तो कोई तो एक precipitating agent add कर देते हैं, and then when you are adding precipitating agent, precipitate will form. And if you have started with 1 gram of substance, and if you got something like 0.5 gram of substance, then just equate it. Okay, so just by equating you will get how much amount of substance is there. Different types we have seen out of gravimetric analysis. For each gravimetric analysis, remember its concept. Then steps involved. Okay, so the question can be which is correct sequence of steps involved in gravimetric analysis. So like if I give preparation of test solution, digestion, filtration, and then precipitation, it will be wrong step, because according to this स्टेप्स इन्वॉल्व क्या है, पहले हम लोग टेस्ट सॉल्यूशन प्रिपेयर करते हैं. ओके, पहले टेस्ट सॉल्यूशन प्रिपेयर करेंगे. आफ्टर प्रिपेयरिंग टेस्ट सॉल्यूशन, what we will do, we will precipitate our metal in some form, and then we'll digest that precipitate. And after digestion, you will filter that solution, washing, drying, weighing. Okay, so these are steps involved, so remember correct sequence of this. Then nature of precipitate. If you have let us say if you have crystalline compound, then it will look like very clear crystals of your compound. If you have amorphous substance, it will look like the amorphous one. Okay, amorphous is curd जैसा दिखता है ना, curd is amorphous in nature. And the जो बड़ा वाला नमक रहता है, it is crystalline. Okay, at your home you can just realize concept of crystalline. Crystals अच्छे से रहते हैं. And in amorphous, your talcum powder is also the amorphous form of substance. Okay, so and if you see filtration, then crystalline compounds can be filtered easily. Amorphous compounds को filter करने के लिए you require Whatman filter paper number 41 or 42. Then gelatinous precipitate is what? Particle size is very low, like colloids. Colloids range in particle size 1 to 1000, 1 nanometer to 1000 nanometer in size. So gelatinous particles are uh, near to colloidal particle side. They are very fine, and you cannot filter out easily. So you require some sintered glass crucible for this is gelatinous. Then this part also we have seen condition for precipitation. So what is solubility? जब भी आप एक सपोज मैंने 1 लीटर वाटर लिया और उसमें कॉमन सॉल्ट ऐड कर दिया, तो एक्सटेंट ऑफ हाउ मच अमाउंट इज डिजॉल्विंग in 1 liter is solubility. Okay, grams per liter. मेरा अगर 100 grams in 1 liter डिजॉल्व हो रहा है, या फिर 250 ग्राम इन आधा किलो भी डिजॉल्व हो गया, तो सोलिबिलिटी क्या होगा? हाफ केजी में कन्वर्ट करना पड़ेगा आपको, 0.5 kg पर डीएम क्यूब. और ग्राम्स में लिया तो 500 kg पर डीएम क्यूब. 500 grams per dm cube will be solubility. So solubility increases as we increase temperature. Like while making sugar syrup, जो दिवाली के टाइम पे बनाते हैं ना sugar syrup, तो while making that what we are doing, we are dissolving sugar in higher amount by heating it. Okay, so for that we heat it. since the basic concept is solubility increases with increase in temperature. This part also we have seen. Then condition for precipitation is the ionic product exceeds solubility product. Okay, this is condition for precipitate. Remember this concept. When molar concentration of its ions, that is ionic product of molar concentration of ions exceeds solubility product, मतलब क्या, वो टाइम पे अभी कंपाउंड डिसॉल्व ही नहीं होगा, इट विल स्टार्ट टू recrystallize. Is your solubility product and ionic product. So condition for precipitation is ionic product exceeds solubility product. Okay, and before that your solution is just saturated or unsaturated. If solubility product is very high, then your solution is just unsaturated solution. If it reaches to ionic product of compound, then condition is saturated condition. Okay, so precipitate you will get after supersaturation. And what are factors affecting it? Common ion effect. Okay, so just remember the sentence that common ion. Okay, I will write here. I hope this is visible to you. Common ion facilitates precipitation and decreases solubility. This is for common ion effect. What common ions do? Common ions decrease solubility of precipitate. Okay, common ions decrease solubility of precipitate and they increase the rate of precipitation, or they facilitate precipitation. They facilitate precipitation मतलब common ion अगर कोई रहेगा, like if you have uh, AgCl as precipitate and if you add externally additional amount of Ag plus ions or Cl minus ions, then the precipitation is favored. Okay, precipitation is favored with common ion and uh, it decreases solubility. Solubility decrease हो रहा है इसलिए तो precipitation हो रहा है. तो remember this trend for common ion effect. Common ion facilitates precipitation and decreases solubility. The next effect we have seen is, this is solubility of precipitate, huh? Solubility of PPT I am writing. You don't write PPT, write it as precipitate. Solubility of precipitate. The next effect we have seen is, okay, there are some numericals on this point. In last lecture we have seen this numerical, but now since the exam will be online, I don't know whether they will allow or not. But how to calculate these types of questions usually come for competitive exams. Okay, to calculate solubility, because in last year, last or just before lockdown that year, for forensic science and one more examination, same problem was chosen. Okay, nothing changed. Same compound, same values, everything was same. For examination in forensic science, um, the class 2 grade, the just entry level examination. So if you are given solubility product of compound, okay, solubility of product compound is given, like BaSO4 is your precipitate and if its solubility is 1 into 10 raised to minus 10 moles per dm cube, what will be its solubility value in water and what will be its solubility value in zero point 0.1 molar H2SO4 was the question. Then if X is solubility, then how BaSO4 dissociates? BaSO4 dissociates as Ba2 plus and SO4 2 minus. So whatever the solubility of BaSO4 is there, that much concentration of Ba2 plus and SO4 2 minus ion is there. Therefore, the solubility product of BaSO4 is concentration of Ba2 plus into concentration of SO4 2 minus. So since Ba2 plus का concentration कितना रहेगा, 1 BaSO4 contains 1 Ba2 plus, so therefore BaSO4 का जो भी concentration रहेगा same concentration रहेगा आपका Ba2 plus का, same way SO4 2 minus का, therefore it will be x square. Since Ksp value is given, you can calculate x, that is solubility of salt in water, will be 10 raised to minus 5 moles per dm cube. Now here water dissociate, water का dissociation कैसे होता है? water का H2O, sorry, H2O will H2 will dissociate, here it should be both way arrow, okay, dissociation हो रहा है तो एक forward arrow रहेगा, एक backward arrow रहेगा, into H plus plus OH minus. Okay, so for dissociation, this is reversible. Okay, reversible arrow will give H plus plus OH minus, or more precisely what it will give you, H3O plus plus OH minus. Okay, so that time you take 2 moles of, you consider 2 moles of water. So since in this example for BaSO4 you don't have any ion common with BaSO4. Okay, BaSO4 में कौन कौन से आयन है? Ba2 plus and SO4 2 minus, and water में क्या है? H3O plus and OH minus. So no ion is common with your precipitate, so therefore water will not affect directly on the solubility of BaSO4. Whereas in case of H2SO4, when H2SO4 is taken as solvent for this precipitation reaction, then for BaSO4 you have sulfate ion, and for H2SO4, H2SO4 will dissociate as twice of H plus plus SO4 2 minus. So for 1 mole of H2SO4, you have 1 mole of SO4 2 minus ions and 2 moles of H plus ions. So this is dibasic acid, we are calling it as. Now due to presence of this sulfate ions in common with your BaSO4 precipitate, what will happen? This SO4 ion also help in precipitation reaction, and due to this common ion, the formation of precipitate will be facilitated by zero point 0.1 times. Okay, this concentration of SO4 2 minus ion will help more precipitation, and hence the will uh, KSP will now change for concentration of Ba2 plus will become now 1 into 10 raised to minus 9. So therefore precipitation is facilitated. Okay, so what common ions do? Common ions decrease solubility. Common ions decrease solubility means they facilitate precipitation. Now reverse is the trend for diverse ion. Okay, for diverse ion trend is different, and for diverse ion effect, solubility of salt increases. Okay, effect, remember the effect, solubility of salt increases for diverse ions. Wait a minute. Um, Remember, students, you will not be provided with any question bank. Okay, we are discussing syllabus, whole syllabus we are discussing. I will not skip any point from syllabus, but everything will be very speedy. Okay, so you just collect everything. I will simplify as possible, as more simple as possible. Okay, so question bank will not be provided to you. Some students are asking me on chat that, ma'am, please provide question bank will not be given to you. uh, डाइवर्स आयन इफेक्ट में क्या याद रखना है? डाइवर्स आयन डिक्रीज what precipitation and they increase solubility. Okay, due to presence of diverse ion increase solubility of compound. So for example, if you have BaSO4 again, if you just add a pinch of potassium nitrate, solubility increases by more than 70%. Then temperature, trend for temperature is solubility as well as solubility product increases with increase in temperature, very common. Then pH, so since pH of reaction affects formation of precipitate, it is very much required to maintain pH of solution. That's why instead of using strong acids or strong bases or like that, instead of using separate compounds, most of times for chemical reaction, if it is pH sensitive, buffer solutions are added. Okay, so buffer solutions, what is their role? They resist sudden change in pH value. So therefore, the um, just change in pH conditions that will affect the precipitation will be avoided. Then we have seen solvents. So polar solvents will like water will always favor dissolution of polar compounds. Okay, and reverse is the condition. Then particle size, how to control particle size. So this is very important practical aspect when you are preparing any inorganic complex or during inorganic preparations or for any type of product formation reaction where you need good amount of product. So that time how you are doing experiment is very important. So uh, how precipitation is done. So precipitation होता है मतलब कोई भी precipitate form होता है, मतलब क्या होता है that time you are taking some starting material. Okay, you are taking some starting material, you are mixing those starting material in some solvent. Okay, तो एक रहेगा लेटेस्ट से आपको मेटल कॉम्प्लेक्स और मेटल सॉल्ट प्रिपेयर करना है, तो एक मेटल का प्रिकर्सर रहेगा वाटर सोल्यूबल, एक दूसरा रहेगा प्रेसिपिटेटिंग एजेंट. सो व्हेन यू आर एडिंग योर मेटल कंटेनिंग कंपाउंड इनटू वाटर, वो डिजॉल्व हो जाएगा. अभी आप ऊपर से क्या ऐड कर रहे हो? उसमें से प्रेसिपिटेटिंग एजेंट ऐड कर रहे हो. सी, अगर आपने एकदम हमने इंस्ट्रक्शन में दिया रहता है कि ऐड 5 ml ऑफ प्रेसिपिटेटिंग एजेंट, कुछ बच्चे ऐसे रहते हैं कि उनको जल्दी जाना रहता है, तो दे आर एडिंग प्रेसिपिटेटिंग एजेंट एकदम विथ वेरी फास्ट रेट, डायरेक्टली 5 ml पोर कर दिया एंड जस्ट स्टर किया, लाइक डमरू बजाते हैं वैसे स्टर किया, हो गया उनका रिएक्शन, दैट्स इट, फिल्ट्रेशन के लिए जाते हैं. बट व्हाट इज हैपनिंग विद दैट प्रेसिपिटेट इज द प्रेसिपिटेट precipitate will not form properly. Okay, and let us see how it will not form. So जब भी first mole of or first atom you can say of metal, if it is combining with first molecule of precipitating agent, there is formation of one nuclei. Okay, there is formation of one nuclei. Similar way, another metal atom will combine with your another precipitating agent molecule and will form nuclei. So this way, when metal comes in contact with your precipitating agent, there is formation of nuclei, and when large number of nuclei form in your solution and they are not grown, all are tiny. Okay, सब छोटे छोटे साइज के रहते हैं, तो all those tiny solution, all those tiny particles, they don't settle. Okay, तो वो क्या रहते हैं, सॉल्यूशन में ही सस्पेंडेड फॉर्म में रहते हैं, एंड दैट solution is called as colloidal suspension, and the size of colloidal suspension is 1 nanometer to 10 raised to 3 nanometer. Remember this digit. Colloidal suspension, okay, colloidal suspension is 1 nanometer to 10 raised to 3 nanometer in size, and since they are very small in size, they remain in suspended form, they don't settle at bottom. यूजुअली कैसे प्रेसिपिटेट फॉर्म हो गया है, प्रॉपरली ग्रोथ हो गया है, तो सब प्रेसिपिटेट सेटल डाउन हो जाता है. यू आर गेटिंग क्लियर सुपरनेट सॉल्यूशन एट द टॉप एंड सेटल प्रेसिपिटेट at the bottom. But if your precipitate is in colloidal form, just form small nuclei, then it will not settle, it will remain in suspended form, and hence it is called as colloidal suspension. And whenever there is if you want good precipitate, you need to grow it. Okay, अभी छोटा न्यूक्लियर फॉर्म हो गया है, जैसे छोटा बच्चा आता है तो वैसे ही आपको उसको बड़ा करना रहता है, तो ग्रोथ is required. So there are two steps of crystal formation or growth. It is nucleation and growth. Okay, nucleation and growth. Let us see what are those. So when your each metal ion is combining, okay, when metal ion is combining with precipitating agent, there is formation of small nuclei. Okay, and these such a small nuclei, if they are in vicinity, like after 12th आप लोग अलग अलग कॉलेजेस में रहते हैं. आफ्टर 12th जब BNBCS में एडमिशन लिया, तो दैट टाइम यू आर कंबाइनिंग इन वन क्लास. ओके, तब किसी को किसी का पहचान नहीं रहता है. ऑल आर वेरी फर्स्ट लेक्चर ऑफ FYBSC, तो सब लोग अलग अलग रहते हैं. आफ्टर सम डेज दे फॉर्म आयन पेयर, तो जो बेंच पे रहते हैं, एक ही बेंच पे बैठते हैं, तो उनका थोड़ा सा दोस्ती हो जाता है. दे लाइक ईच अदर, फ्रेंडशिप हो जाता है उनमें, और फिर आयन पेयर इज फॉर्म. सो जस्ट दोनों में नहीं, कितना भी बड़ा ग्रुप हो सकता है. तो likewise clustering of ion pairs form. So very first stage is nuclei, formation of single nuclei, then nuclei combine to form ion pair. Okay, ion pair is second step. After formation of ion pair, these ion pairs combine to form a cluster of ion pairs, and this cluster grows further to form a big crystal. So formation of ion pair leads to formation of big crystal. So union of ion pairs is required, so that after formation of big cluster there will be formation of crystal. So this mechanism gives you how crystal is formed. Now there are two types of formation of crystal, by heterogeneous nucleation and by होमोजेनियस न्यूक्लिएशन. ओके, जब भी ये क्लस्टर फॉर्म हो जाता है, तो क्या हो जाता है, एक सेंट्रल में बैठता है लाइक टीम लीडर. ओके, और वो टीम लीडर सबको कनेक्ट करके रखता है. आप में आपके ग्रुप में भी रहता है ना ग्रुप एडमिन. ग्रुप एडमिन डज, तो सबको कलेक्ट करके एक साथ रखता है, तो योर ग्रुप इज फॉर्म्ड एंड इज स्टेबल. सो सेम वे होमोजेनियस न्यूक्लिएशन में क्या रहता है, होमोजेनियस न्यूक्लिएशन इज लाइक लोकशाही. All are leader. Okay, all are leader. So every individual is having its right. So in homogeneous nucleation, there is all ion pairs, they cluster together and form the big crystal. Okay, in heterogeneous nucleation is like China. तो उसमें क्या रहता है, there is no Lokshahi. One leader is there, like your foreign particle is there, and remaining particles they grow on the surface of that. It is like a dust particle, like your dust particle can be a nucleation center. Okay, so any foreign particle act as nucleation center. Any foreign particle act as nucleation center, and remaining particles remaining particles, they grow over the surface of that foreign particle. So in this image you can see there is central particle, and then rest of particles are deposited over the surface of that particle. So this you can say heterogeneous nucleation. If it is homogeneous nucleation, the central nuclei and surrounding particles all are same. So two mechanisms are there. Heterogeneous nucleation is the process in which the crystal is formed by clustering ions around any other foreign particle. Okay, so you require some other, like dust particle can be a nucleation center, or some impurity metal can be a nucleation center. So in heterogeneous nucleation center is foreign particle. Foreign particle मतलब क्या, बाहर के देश का नहीं, other than your precipitate. अगर BaSO4 का precipitate form होने वाला है, and if it contains some amount of AgCl as precipitate, और AgCl का अगर एक मोलिक्यूल भी रहेगा, एक न्यूक्लियाई भी रहेगा, तो उसके ऊपर अगर BaSO4 आपका precipitate हो रहा है, तो that can be a heterogeneous nucleation. और रिएक्शन करते टाइम आपने कुछ डीप करके रखा उसमें, और उसके ऊपर अगर न्यूक्लिएशन हो रहा है, तो that can also be heterogeneous nucleation. Homogeneous के लिए कैसे, amongst themselves the nucleation takes place just by clustering together. Okay, then according to this scientist von Weyman, he studied nucleation process, and what he observed that if you do precipitation process at very faster rate, then you will not get fine crystals out of your material. Okay, so faster the precipitation, smaller is particle size. अगर आपने एकदम बल्क में 5 ml ऐड करने के लिए हमने इंस्ट्रक्शन दिया था, बट आगे वाला सुना ही नहीं, ऐड 5 ml ऑफ प्रेसिपिटेटिंग एजेंट ड्रॉप बाय ड्रॉप, आपने वो सुना ही नहीं रहता है. ऐड 5 ml बोला कि एकदम ऐड कर दिया वेरी फास्ट स्टूडेंट्स, तो पार्टिकल साइज क्रिस्टलाइन नहीं मिले क्रिस्टल्स, आपको एमोर्फस मिला. जब प्रेसिपिटेट फिल्टर करने के लिए गए तो सीधा वो फिल्टर पेपर के नीचे आया और आपको प्रोडक्ट मिला एकदम कम. सो दैट इज बिकॉज you are adding your precipitating agent very fast. To avoid that, what he told that supersaturation plays an important role. Supersaturation मतलब क्या, when your ionic product reaches solubility product, ulta solubility product reaches ionic product, when both the values are same, then saturation condition is there. So relative supersaturation according to him is Q minus S upon S. Okay, Q minus S upon S, where this Q, capital Q minus S, is supersaturation at that moment, when at the moment precipitation starts. Okay, when your ionic product reaches solubility product, if both are same, your supersaturation condition is done. Now the this is supersaturation at the moment of precipitation. अगर दोनों प्रोडक्ट सेम है, योर सॉल्यूशन इज सैचुरेटेड वन. when ionic product exceeds solubility product, at that moment, when 0.1 difference will come, at that moment your precipitation will start. Okay, so that is your Q minus S supersaturation condition, where Q alone is molar concentration of your starting material. Okay, Q is molar concentration of mixed reagent, whatever the starting reagents you have taken is Q, उसका concentration 0.1 मोलर का लिया था या 0.2 मोलर का लिया था, तो that is your Q value. And S is molar solubility of precipitate. This is not of reagents, this is solubility of precipitate. So now if you want your uh, compound, if you want your compound to be more soluble, or if you want your compound if you want your compound more crystalline, what you will do? So there are two techniques when you are preparing your compound. These are not actually the techniques, these are practical observations, how you are getting amorphous compound and how you are getting crystals out of your stirring process. जब आप लोग स्टर करते हो ना वेरी फास्ट फास्ट फास्ट, तब क्या हो जाता है? तो ड्यूरिंग दैट प्रोसेस, सी आपने कंपाउंड लिया, स्टार्टिंग में रिएजेंट, डिसॉल्व इट इन वाटर, start adding precipitating agent. When you are adding precipitating agent quickly, 5 ml का 5 ml एकदम वन शॉट में ऐड कर दिया, तो योर मेटल जो सॉल्यूशन में रहेगा, बीकर में रहेगा, उसको बहुत सारा खाना मिल जाता है. प्रेसिपिटेटिंग एजेंट इज इट्स खाना. तो सभी मेटल आयंस को एट अ टाइम खाना मिला. व्हाट विल हैपन? every metal ion will react with precipitating agent and there is formation of large number of small nuclei. Okay, लार्ज नंबर ऑफ स्मॉल न्यूक्लियाई, बहुत सारे छोटे छोटे न्यूक्लियाई फॉर्म हो गया, बहुत सारा पॉपुलेशन. नाउ बिकॉज ऑफ दिस ह्यूज अमाउंट ऑफ पॉपुलेशन, तो each each individual nuclei, what will do according to the which rule? Biology, struggle for existence. Okay, so each nuclei will start to grow and will what it will eat whatever feed is available in surrounding of that nuclei. तो बहुत सारे न्यूक्लिया है और स्पेस इतना ही है, तो उनको खाना कम मिलेगा, उनका ग्रोथ भी कम हो जाएगा. यू कैन अंडरस्टैंड. सो if this is happening, if you are adding precipitating agent very fast, so large number of nuclei will form. Okay, so number of nuclei is more, in that case, so therefore your precipitate will be amorphous. क्योंकि उसका ग्रोथ ही नहीं हुआ तो वो छोटू पार्टिकल साइज रहेगा, is your amorphous powder. Now in another case, किसी को घाई नहीं रहता है घर जाने का, प्रैक्टिकल अच्छे से करना रहता है, तो what that student will do, will listen instruction of teacher carefully and will add precipitating agent drop wise. Now what will happen? First drop of precipitating agent comes, it will form one nuclei. Second drop of precipitating agent will come, it will form another nuclei. So this way very low number of nuclei will form initially, and when he will go on adding these now nuclei, वो सीनियर रहेंगे, वो जूनियर पे रैगिंग करेंगे, और those freshly prepared nuclei, what will they do? जो फ्रेशली आए रहेंगे न्यूक्लियाई आफ्टर एडिशन ऑफ लेट अस से 10th वाला ड्रॉप, तो वो ये सीनियर वाला क्रिस्टल छोटे क्रिस्टल को खा जाएगा. सो देयरफॉर ये सीनियर क्रिस्टल्स विल ग्रो और वो छोटे छोटे क्रिस्टल्स विल डिसॉल्व एंड रीडिपॉजिट ऑन सरफेस ऑफ large crystal. This is called as Ostwald's ripening. That concept we will see later. But this is another method when you are adding your precipitating agent slowly. Okay, precipitating agent अगर आपने slowly add कर दिया, तो this is happening. You can see in both these images. एक में बहुत सारे क्रिस्टल्स है. ओके, एक में बहुत सारे छोटे छोटे न्यूक्लियाई फॉर्म हो गए. वो हर एक न्यूक्लियाई विल ट्राई टू ग्रो. इसके एनवायरनमेंट में जितना भी खाना रहेगा खाएगा, बट एनवायरनमेंट में खाना ही कम रहेगा तो सबको नहीं मिलेगा, सबका ग्रोथ छोटा हो जाएगा. ये केस में क्या है आपका, ब्लू वाले केस में ऐड स्लोली कर रहे हैं, तो जैसे ही आ रहा है, अभी ये बड़ा हो गया ना, जैसे ही छोटा क्रिस्टल फॉर्म हो गया, ये बड़ा क्रिस्टल छोटे को इमीडिएटली खा जाएगा. ओके, इधर क्या हुआ था, सब एट ए टाइम फॉर्म हो गए थे, लाइक ट्विन, दोनों का बर्थ एट ए टाइम हुआ है, तो देयरफॉर ग्रोथ ऑफ दीज क्रिस्टल्स विल टेक प्लेस, वेरी गुड, खाते पीते घर का बच्चा ये हो जाएगा, ये रहेगा जिसमें खाना नहीं मिलेगा। ओके, तो डोंट टेक इट सीरियसली, जस्ट फॉर एग्जाम्पल आई एम टेलिंग यू कि कैसे क्रिस्टल का ग्रोथ होता है। तो इफ वी आर कॉलिंग दिस एज केस ए, इफ दिस इज योर केस बी, then in case of case A you will get amorphous precipitate, in case of case B you will get crystalline precipitate. So if you want to get crystalline precipitate, then try to add precipitating agent slowly with constant stirring. Also, according to scientists, q minus s upon s if it is large, okay, q minus s upon s if it is large, then particle size tend to be colloidal. ओके, ये वाला वैल्यू अगर बहुत ज्यादा आया तो आपका पार्टिकल साइज कोलाइडल होता है, मतलब आपको क्या मिलेगा, एमोर्फस सब्सटेंस मिलेगा। क्यों? क्योंकि लार्ज नंबर ऑफ न्यूक्लियाई विल बी देयर, सारे न्यूक्लियाई रहेंगे, इसलिए आपको एमोर्फस पार्टिकल साइज मिलेगा। दैट इज व्हेन q minus s upon s is large. Okay, when q minus s upon s, this value if you are getting small, okay, if you are getting small, that is solubility of precipitate ज्यादा रहेगा और solubility of precipitate ज्यादा रहेगा और q minus s सुपर सैचुरेशन का कम रहेगा, that time you will get, if you will get it small, particle size tend to be more crystalline. Okay, तो what is target in gravimetry? ग्राविमेट्री का एम क्या है, आपने एनालिसिस करने के बाद प्रेसिपिटेट लाना है, ओके, और वो प्रेसिपिटेट का वेट बैलेंस पे मेजर करना आना चाहिए। अगर प्रेसिपिटेट का वेट वेइंग बैलेंस पे मेजर ही नहीं कर सकते तो ग्राविमेट्री का कुछ यूज ही नहीं हुआ ना। तो व्हाट यू विल ट्राई टू गेट, whether you will prefer crystalline compound or amorphous, definitely you will prefer क्रिस्टलाइन कंपाउंड्स। ओके, तो क्रिस्टलाइन कंपाउंड पाने के लिए कंडीशन क्या आना चाहिए, q माइनस एस अपॉन एस इज स्मॉल। तो ये वैल्यू अगर स्मॉल लाना है, इफ यू वांट दिस वैल्यू स्मॉल टोटल, तो व्हाट यू विल डू, आइदर यू विल इंक्रीज वैल्यू ऑफ s, ओके, if you will increase value of s, then total value will be small, ये वैल्यू नीचे का बड़ा रहेगा तो टोटल ये डिवाइडेड बाय ये भी छोटा आएगा। अदरवाइज इफ यू लोअर वैल्यू ऑफ q का वैल्यू छोटा रहेगा तो भी ये वैल्यू स्मॉल आएगा। तो lowering of q value, okay, lowering q value can be done, कैसे होगा, what is q? q क्या है, q is nothing but molar concentration of your starting materials. Okay, so molar concentration अगर starting material का कम लिया, मतलब क्या, instead of taking 1 molar, if I take 0.1 molar मैंने, तो I am getting good crystalline precipitate. So don't allow to make crowd, don't allow to make crowd, अगर crowd हो गया तो particle size amorphous ही मिलने वाला है। So to get good crystals, either use diluted solutions, starting materials, use diluted solutions of substance, or else what you can do for lowering of q, add precipitating agent slowly, okay, add precipitating agent slowly with constant stirring, so these two will give you लो वैल्यू ऑफ q। लो, q का वैल्यू लो लाना है तो सी क्वेश्चन कैन बी, if you want to get good crystalline precipitate, what can be condition of supersaturation? तो supersaturation condition should be q minus s upon s is small for crystalline precipitate। अगर ये आपको small लाना है तो what you will have to do, supersaturation condition ये वैल्यू स्मॉल लानी है तो आइदर यूज डाइल्यूट स्टार्टिंग मटेरियल्स और दोनों एक साथ भी कर सकते हैं, एंड और Add precipitating agent dropwise with constant stirring. और अगर S का वैल्यू बड़ा लाना है तो S is what is your S? S is molar solubility of your precipitate. So this solubility, what is trend of solubility? Solubility increases with increase in temperature. So therefore, if you want a good precipitate, crystalline precipitate, use reaction condition of higher temperature. Okay, use hot solution. Instead of stirring your reaction mixture at room temperature, just warm your solution and then do gravimetry. So also it requires adjusting pH. Okay, if you don't adjust pH of solution properly, then you know many times in main group element properties we have seen that changes. So to make it very good, just adjust pH and use in general, if you want good crystalline precipitate, then add to your hot solution dilute solution of reacting species with very constant stirring. So use dilute solutions, starting material dilute solutions, add precipitating agent dropwise with constant stirring, and use hot solutions. So three conditions will give you very good crystalline precipitate. Any doubt in this, how you will get crystalline precipitate? I hope there is no doubt. You can put it in chat box. Any problem up to this? Okay, very good. So remember this, how you will get crystalline precipitate. Lower value of Q using dilute solutions, add precipitating agent dropwise with constant stirring, and use hot solutions. Okay. Now the next is how colloidal solutions are formed and the stability. Is this very good, Pooja? YouTube live is, I think, going on. If you find some difficulty, YouTube live while students, you can put it in chat box of YouTube live or WhatsApp me. Okay, now let us see about colloidal solutions. As I told you, colloidal particles are 1 nanometer to 10 raised to 3 nanometers. Okay, when your first ion pair is formed, then it is of 10 raised to minus 9, it is of 10 raised to minus 1 nanometer, that is zero point 0.1 nanometer. When nuclei form, that is by clustering of ion pairs, this nuclei is of 1 to 10 nanometer. Okay, and when it grows 2-3 layers of nuclei, that particle size is 1 to 10 raised to 3 nanometers. Okay, and above that, if particle size exceeds, then you will get precipitate, which you can see by next. So the turbid precipitate, or what your crystalline precipitate, is more than 10 raised to 3 nanometer in size. Okay, so what is this colloidal state? Colloidal state मतलब क्या? What is this colloidal state? Colloidal state मतलब क्या? Any idea? The particles remain in suspended form. Okay, particles remain in suspended form. Just remember about size of colloidal particles. Now just see this mechanism of colloidal particles. Just focus on first part of this slide. Okay, ये second वाला part I will explain you later. Now if you want to precipitate AgCl, if AgCl is your precipitate, then common ion will help you for increasing precipitation. Okay, common ion facilitates precipitation. So for AgNO3, if you have AgNO3 solution and if you add NaCl, small amount of NaCl in AgNO3, what will happen? There will be formation of AgCl precipitate. अभी क्या है, आपने NaCl, if NaCl is your precipitating agent एंड इन सॉल्यूशन ऑफ AgNO3 का बॉटल रहेगा और उसने उसमें आपने वन ड्रॉप ऑफ NaCl डाल दिया, तो व्हाट विल हैपन? देयर विल बी फॉर्मेशन ऑफ लिटिल नंबर ऑफ, वेरी फ्यू नंबर ऑफ AgCl प्रेसिपिटेट. AgCl का एक मोलिक्यूल फॉर्म हो गया इफ वी ऐड वन मोलिक्यूल ऑफ NaCl. तो सॉल्यूशन अगर देखा, since your solution host solution is of AgNO3, AgNO3 का host solution रहेगा तो उसमें Ag plus आयन बहुत ज्यादा रहेंगे, NO3 माइनस आयन्स भी बहुत ज्यादा रहेंगे. समझ रहा है? एंड your H plus आयन, H3O plus आयन, OH minus आयन्स will be very low in number, क्योंकि वो सॉल्वेंट वाटर के या फिर ये Na plus के Cl minus के रहेंगे, वो बहुत कम नंबर में रहेंगे. तो what will happen when you are adding small amount of NaCl into AgNO3. AgNO3 आपका होस्ट है, तो पूरा AgNO3 का ही लाइक कैसे हुआ? अभी SYB डिवीजन का लेक्चर है और मैंने PC वाले स्टूडेंट्स को SYB डिवीजन में जाके बैठने के लिए बोला. ओके, तो दैट वे योर होस्ट इज AgNO3 and your guest is NaCl. Okay, NaCl is guest, AgNO3 is host. So when first molecule of AgCl forms, its size will be just 0.1 to 1 nanometer. Okay, very small size, just we have seen. Then since your host is AgNO3, which is common ion in precipitate, precipitate में ions कौन है? This AgCl is having Ag plus and Cl minus. ओके, तो जो होस्ट है उसमें कॉमन आयन है Ag plus. Okay, so therefore those all Ag plus ions will form a layer of positively charged ions surrounding that AgCl. So this positively charged first layer is called as primary layer. Okay, जो common ions रहेंगे, those common ions will remain adhered around the surface of your first form particle AgCl. So this is your primary layer. Now in solution now remaining ions are NO3 minus and very less number of Cl minus Na plus will be there. So since NO3 minus ions are negatively charged, they will be now attracted towards this first layer of positively charged Ag plus ion. So now NO3 minus ion will form second layer, which is called as secondary layer. So there is formation of electrical double layer around each colloidal particle. You are getting? जब भी एक कोलाइडल पार्टिकल फॉर्म होता है तो जो भी कोलाइडल पार्टिकल में कॉमन आयन रहेगा, सॉल्यूशन का वो कॉमन आयन इधर AgCl का Cl आयन आपने कितना डाला था? स्मॉल अमाउंट ऑफ NaCl. तो Cl का लेयर नहीं बनेगा इधर, क्योंकि Cl डालते टाइम ही बहुत कम डाला था. बट इन योर होस्ट यू हैव Ag plus आयन इन प्लेंटी ऑफ अमाउंट, देयरफॉर Ag plus का लेयर पहले बनेगा, दैट यू आर कॉलिंग primary layer, and after that negative charge layer will come, and since Cl ion बहुत कम है तो Cl का लेयर नहीं बैठेगा इधर, NO3 माइनस का लेयर बैठेगा. अगर Cl का बनता तो वो AgCl easily फॉर्म होता, but now NO3 will form another layer. So this way there is formation of electrical double layer, and this electrical double layer protects your centrally placed particle of precipitate from growing. अभी इसके विसिनिटी में कोई आ सकता है क्या? इधर से कोई पार्टिकल आया तो Na3 का एक लेयर उसके ऊपर डुशुम डुशुम करेगा. There will not be reaction directly with AgCl. Hence AgCl will form and will remain in suspended form only. Okay, क्योंकि वो electrical double layer से protect है. Same way, if we add small amount of AgNO3 into NaCl, now host is what? NaCl is your host और उसमें आप लोग AgNO3 डाल रहे हैं. So as soon as you add AgNO3 to NaCl, there will be formation of AgCl. ओके, तो AgCl फॉर्म हो जाएगा. अगर एक ही ड्रॉप, एक ही मॉलिक्यूल AgNO3 का ऐड किया है तो AgCl का एक ही मॉलिक्यूल फॉर्म हो जाएगा. सो नाउ इन दिस केस, सिंस योर होस्ट कंटेन्स Cl minus ions in common with AgCl, these Cl minus ions will be will surround your host, you will surround your precipitate molecule and will form primary layer. Cl का प्राइमरी लेयर कब फॉर्म होगा? when your host lattice contains negatively charged ion common with precipitate. Okay, so there will be formation of primary layer negative, and then your host Na plus ions which are in plenty will form secondary layer. Again, in this case there is formation of electrical double layer. This electrical double layer will protect your centrally placed molecule फ्रॉम प्रेसिपिटेटिंग. तो ये प्रेसिपिटेट नहीं, बड़ा वाला प्रेसिपिटेट, इसको ग्रोथ को चांस ही नहीं मिलेगा. ग्रोथ कब होगा? व्हेन दिस AgCl विल कंबाइन विद दिस टू फॉर्म आयन पेयर. आयन पेयर फॉर्म होने के बाद क्लस्टर फॉर्म होगा, न्यूक्लियर फॉर्म होगा. बट इधर न्यूक्लिएशन के लिए चांस ही नहीं मिल रहा है क्योंकि बोथ आर प्रोटेक्टेड बाय इलेक्ट्रिकल डबल लेयर. So to break that electrical double layer, what we'll have to do, will have to add some precipitating agent, that is some external reagent which contains common ion. Okay, so when you will add now further amount of NaCl, okay, और ज्यादा NaCl मैंने add कर दिया, तो because of that extra amount of NaCl, the Cl minus ion can reach to Ag plus and there will be formation of AgCl again. So you require to add some common ion containing compound here. Now if you have choice of adding NaCl, Na2SO4 and Na3PO4, precipitation increase कब होगा? When you will add common ion. But common ion में भी common ion containing compound, if you have variety like NaCl, Na2SO4 or Na3PO4, which you will prefer? You will prefer the common ion containing compound in which charge of ion is more. Okay, so इधर NaCl में how many positive charges are there? Only one. In Na2SO4, when you will dissociate, you will get twice of Na plus SO4 minus. So when you are adding 1 mole of each, for NaCl 1 mole, you are getting only 1 mole of Na plus. But here for 1 mole of Na2SO4, you are getting 2 moles of Na plus. Okay, and again if you change, instead of Na2SO4, if you add Na3PO4, then for 1 mole of Na3PO4 you have 3 moles of Na plus. So now एक एक ही ड्रॉप में आपको एक ड्रॉप ऑफ Na3PO4 is giving you 3 numbers of Na plus ions. समझ रहा है? तो therefore you will select the more charged molecule for as common ion in addition. Okay, now what are impurities in precipitation are uh, impurities comes during the process of co-precipitation and post-precipitation. Co-precipitation is during the reaction. Okay, if some dust particle or something is there, if foreign particle is there, and over that particle, if your growth of crystal takes place, then it is co-precipitation. Now in co-precipitation, one of the concept is occlusion. Occlusion is what? Trapping of impurity ड्यूरिंग क्रिस्टल ग्रोथ. ओके, ऑक्लूजन प्रोसेस होता है मतलब क्या, ट्रैकिंग ऑफ ट्रैपिंग ऑफ impurity during the crystal growth on the surface of foreign particle. So is your occlusion, and there can be some surface impurities also. So two types of mechanisms are there, either by occlusion or by adsorption. Another is post precipitation. Post precipitation is during the time of digestion. If uh, it happens like uh, if in post precipitation the impurities incorporate after the formation of precipitate. Okay, during the precipitation mechanism there were no impurities, but they come after precipitation, so therefore they are called as post precipitation methods of involving impurities in. And of course you can uh, remove those during the process of washing. How you will confirm precipitation is done or not? So go on adding precipitating agent. मैंने क्या बोला था? Add 5 ml of precipitating agent to check whether precipitation is done or not. Allow your solution to settle. Okay, allow your solution to settle. सेटल होने की बात क्या हो जाएगा, जितना भी प्रेसिपिटेट फॉर्म हो गया है वो टर्बिड सॉल्यूशन, उसमें से प्रेसिपिटेट नीचे सेटल हो जाएगा ऊपर. व्हाट यू विल गेट क्लियर सॉल्यूशन. Supernatant solution will be clear. So on that supernatant solution, from the side of your beaker, just add few drops of, and if there is no change on that top layer, जो ऊपर का क्लियर लेयर था उस पे कुछ भी चेंज नहीं हो रहा है, लाइक यू इफ यू डोंट ऑब्जर्व फॉर्मेशन ऑफ प्रेसिपिटेट देयर, then precipitation is completed. Okay, so this is just test whether to continue adding precipitating agent or not. So allow your precipitate to settle and check there is formation of precipitate or not. Now next process is digestion. Digestion is what? Digestion is growing your crystal. Okay, शुरू में compound crystal बहुत छोटा था, अभी आप लोग उसको बड़ा कर रहे हैं. तो this is Ostwald's ripening. The process is known as Ostwald ripening. Ostwald ripening में क्या होता है, आपका जो पहला सीनियर क्रिस्टल रहता है, ओके, सीनियर क्रिस्टल्स रहेंगे और कुछ छोटू क्रिस्टल भी रहेंगे. दो छोटू क्रिस्टल्स dissolve and redeposit on the surface of big crystal. Okay, small nuclei or small crystals dissolve and redeposit on the surface of large crystal to form big crystal. और बड़ा फॉर्म हो जाएगा. छोटे छोटे क्रिस्टल सॉल्यूशन में डिसॉल्व होके बड़े क्रिस्टल पे रीडिपोजिट होते हैं. इज योर Ostwald's ripening, or it is also called as digestion. Digestion is process of making big crystals out of small crystals. तो छोटे छोटे न्यूक्लियाई जो फॉर्म हो गए उनका प्रॉपर ग्रोथ करना is your process of aging or digestion, and is based on Ostwald's ripening law. Ostwald's ripening law is what? Crystals dissolve and redeposit on the surface of big crystals is Ostwald's ripening law. Okay, so this is your process of digestion. Digestion can be of half an hour, can be 1 hour, can be 1 day, can be 1 week, can be 1 year for many natural reactions. Okay, so for your chemical reaction in lab, we usually give you digestion of half an hour or 1 hour, like that. Okay, then next process is filtration. Once you get good crystalline precipitate, then you can filter, and you have different choices of filtration. If you have fine powder, amorphous or gelatinous powder, then you need to select a very specific filtration mechanism. If you have crystalline precipitate, you can filter with just Wortmann filter paper number 1, either by simple filtration or using vacuum filtration where Buckner funnel is used. Okay, this performed in your regular practical, so you know what is Buckner filter paper, Buckner funnel, and Wattman filter paper. And if you have gelatinous precipitate, then sintered glass crucible. Okay, sintered glass crucible is used for filtering out gelatinous precipitate. This method is called as counterpoise method. Okay, counterpoise method में you are using sintered glass crucible. So where you need to apply pressure in vacuum filtration. Then washing of precipitate. This is again very important. आपको washing देने के लिए बोलते हैं. Why washing is necessary? This washing is necessary to remove soluble impurities. Okay, if you have some soluble impurities, then soluble, sometimes non-volatile, then those can be removed using some particular solvent. And there are properties of washing solution. You can select your washing solution in such a way that it should have no action on precipitate. That is, it should not react chemically with your precipitate but have capacity to dissolve impurity. अगर उसमें impurity हो जाएगा होगा तो your precipitating agent should dissolve your impurity, and it should not react with your this thing precipitating agent with your precipitate. Okay, क्योंकि अभी फनल पे रहेगा ना प्रेसिपिटेट, तो प्रेसिपिटेट के ऊपर जब आप लोग washing solution डालते हो, तो that washing solution should not take away your precipitate. It should selectively dissolve impurity. Then it should be volatile at temperature of drying. अगर आप लोगों को precipitate stable रहेगा तो you can dry it above 100 degree Celsius also. If your precipitate decomposes early, then you will use some volatile precipitate. So this washing solution, like if your precipitate is decomposing by 80 degrees Celsius, then you can use acetone or like those solvents for washing. Okay, but many a times water is preferred for this if precipitate is insoluble in water. Now, how many times you will give washing? Okay, if I'm telling you give washing of washing to precipitate of 100 ml solution. Okay, 100 ml solution मैंने आपको दिया है, तो कुछ बच्चे ऐसे रहेंगे जिनको घाई है, वो 100 ml का 100 ml पूरा solution उसमें ऐड कर देंगे and they will wait for some time. Okay, तो क्या हो जाएगा, since you are applying vacuum from the bottom, तो वो 100 ml solution जल्दी पास हो जाएगा. कुछ बच्चे ऐसे रहेंगे कि अरे 100 ml तो अगर मेरा पेपर फट गया तो दे विल थिंक ऑफ, तो क्या करेंगे, वो पहले 50 ml डालेंगे बाद में 50 ml डालेंगे. तो ये सेकंड कैटेगरी ऑफ स्टूडेंट्स. कुछ ऐसे रहेंगे कि उनको प्रैक्टिकल बहुत अच्छे से करना है. व्हाट दे विल डू, शुरू में 10 ml डालेंगे, दे विल वेट फॉर सम टाइम, वो सॉल्यूशन नीचे जाने देंगे और 10 ml डालेंगे और 10 ml डालेंगे. तो दिस वे योर वॉशिंग सॉल्यूशन इज गेटिंग सम टाइम टू रिएक्ट विथ हिडन इम्प्यूरिटीज. तो प्रेसिपिटेट में डायरेक्टली ऊपर इम्प्यूरिटीज ऐसे ऊपर आके नहीं बैठेंगे ना, मैं अभी वॉशिंग सॉल्यूशन को कैच करूंगा, डिजोल्व हो जाऊंगा और नीचे जाऊंगा, ऐसे नहीं होगा. दे विल बी हिडन बिलो योर प्रेसिपिटेट. सो इन ऑर्डर टू गेट रिमेंबर, दिस इज इंपॉर्टेंट प्रैक्टिकल एस्पेक्ट. वॉशिंग सॉल्यूशन को देते हैं, क्यों देते हैं प्रेसिपिटेट को वॉशिंग? cause to remove impurities, soluble impurities को remove करने के लिए, तो give some time for your washing solution to find out impurities in your lattice of crystal. Okay, lattice of your precipitate. बहुत सारा उधर precipitate रहेगा, उसमें से impurity को ढूंढने के लिए time लगेगा ना washing solution को. So use small fractions of washing solution to get better precipitate. Okay, अगर clean precipitate चाहिए तो use more and more fraction. ये तीन चॉइस में व्हाट विल बी योर चॉइस? एड 10 10 ml इन फ्रैक्शंस, क्योंकि पहले स्टूडेंट ने क्या किया था, 10 ml एक 100 ml का 100 ml एक ही बार यूज किया था। सेकंड ने क्या किया था, 50 50 के दो फ्रैक्शन ऐड कर दिए थे। थर्ड ने क्या किया था, 10 10 के 10 टाइम्स ऐड कर दिए। एक ऐसा बच्चा रहेगा वेरी स्लो, 5 5 के 20 भी ऐड कर सकता है, बट वो 5 5 ऐड करने वाले को बहुत ज्यादा प्योरिटी मिलेगा। सो this is how washing solution is added. Take precaution that you will add washing solution in many batches, not in bulk. Okay, then drying and ignition. This process is required to remove your water of crystallization and water present in uh, the around the crystal. So usually after filtration, this is done, and drying temperature is selected। जो भी आपका वॉशिंग रिएजेंट रहेगा उसके मॉलिक्यूल, सॉल्वेंट मॉलिक्यूल्स रिमूव करने के लिए यूजुअली 100 to 150 डिग्री सेल्सियस पे ओवन में रख के वो ड्राई करते हैं। ओके, देन ignition is what, once your product gets dried, it is associated with your filter paper. So to get exact weight of your filter paper, ignition is done. So ignition is also called as incineration. Okay, incineration, its spelling is incineration. Incineration is burning of your filter paper. Burning of paper is done in two methods, in two ways। दो अलग अलग वेज में ये करते हैं। तो वन वे इज बर्निंग ऑफ योर फिल्टर पेपर और इंसिनरेशन ऑफ योर फिल्टर पेपर, sorry, of your product in presence of filter paper and in absence of filter paper। in presence of filter paper is very common practice in your lab। तो what you are doing, आप लोग वो पेपर का फोल्ड करते हो, क्रूसिबल में भरते हो, एंड द पेपर इज कार्बोनाइज्ड। ओके, पेपर इज कार्बोनाइज्ड। वो पेपर को स्लोली हीट करके वो पेपर को कार्बोनाइज करता है। एंड ये पेपर कैसा रहता है, वॉटमैन फिल्टर पेपर, इट्स property is like when you burn Whatman filter paper, then the ash you are getting in crucible is wetless। वेटलेस मतलब कितना रहता है, फॉर वॉटमैन फिल्टर पेपर नंबर 41 the ash you are getting is of 0.00001 gram, 5 times 0 and after 1। so this is the quantity of filter paper which is which is not detectable on your regular balance। so this is not affecting for your gravimetry। so there are two methods, burning of ppt with filter paper and another one is without filter paper। okay, two methods are there, burning with and without filter paper। so this is called as incineration mechanism, incineration process। so this ignition is done to remove the water and to dry your compound carefully। if your precipitate is very stable, you can just remove only moisture, okay, by this way। once you get your weight of compound, the final step will be just weighing of your compound, and then with equating it with solution taken for analysis। okay, so these are different steps involved in gravimetric analysis। remembers points under each step carefully। This during ignition process or drying process, what is happening? Your कंपाउंड इज स्टडीड विद रिस्पेक्ट टू डिफरेंट टेम्परेचर. ओके, शुरू में रूम टेम्परेचर रहेगा, रूम टेम्परेचर से लेके 50 डिग्री सेल्सियस तक टेम्परेचर इंक्रीज किया, और आगे इंक्रीज किया 100 तक, 150 तक, 200 तक, 250 तक. तो in gradient you are increasing temperature, so with different slots of increasing temperature you are getting some weight losses, and that weight loss is not of your compound. The whatever impurities or other foreign particles present in your compound are getting lost. So this you can analyze with the help of thermogravimetry also. Okay, and that is called as pyrolysis curve or thermogravimetric curve of your compound. TG curve, TG, thermogravimetry. Okay, now in application part we will see very quickly applications of gravimetric analysis. For your syllabus, 3 applications are quoted in book. One of application is determination of sulfur in organic compound. In organic compound आपका organic compound रहेगा like कौन सा भी एक compound बताओ मुझे. थायोयूरिया. ओके, थायोयूरिया में है सल्फर. So if thiourea is your compound, then you can analyze sulfur from thiourea. The process is known as Carrier's method of analyzing. In this, what is done in this method? Remember, the reagent used for analysis of sulfur is sulfur present in your organic compound, means organic compound, pinch of organic compound is taken and is oxidized with sulfuric acid. Okay, in first step it is it is oxidized to sulfuric acid by digesting it with fuming nitric acid. So nitric acid, fuming nitric acid is very strong nitric acid, pure you can say. Nitric acid is used to oxidize sulfur to sulfuric acid. So reagent used in this is nitric acid. Nitric acid is used to oxidize sulfur to sulfuric acid. So you can write the reaction sulfur S plus HNO3 gives you sulfuric acid. Okay. Now whatever sulfuric acid is formed, okay, is precipitated as barium sulfate. So that time you need to add barium chloride. Barium chloride is water soluble. When you add barium chloride in sulfuric acid, there will be formation of precipitate of barium sulfate, which is sparingly soluble. So by measuring weight of barium sulfate, you can find out how much sulfur is present. The 1 mole of barium sulfate corresponds to 1 मोल ऑफ सल्फर. बैरियम सल्फेट में कितने सल्फर है? एक ही है. तो जितना भी बैरियम सल्फेट का वेट लिया रहे, यू जस्ट इक्वेट टू फाइंड आउट amount of sulfur present in your sample. So for this process, just remember sulfur is oxidized to sulfuric acid using nitric acid. Okay, nitric acid is used in this process to oxidize. Nitric acid is your oxidizing agent to convert organic sulfur to sulfuric acid. और precipitating agent कौन यूज किया है? Barium chloride is precipitating agent. Okay, 2 sentences याद में रखो. Nitric acid is oxidizing agent and barium chloride is precipitating agent. This is how the estimation is done. Then just by equating 1 mole of barium sulfate corresponds to 1 mole of sulfur, you can find out weight of sulfur. Okay, then for alloys क्या है? Alloy is homogeneous mixture of 2 or more metals. अगर एक होस्ट मेटल में मैंने बहुत सारे मेटल्स ऐड कर दिए, तो वो बहुत सारे मेटल कितने परसेंटेज में प्रेजेंट है, that we can determine. So that method is estimation of some metal ion, another alloy. So for this if you have copper nickel alloy, if you have copper nickel alloy, then in this copper you will have to first remove, because copper forms black precipitate with H2S gas. वो solution में अगर copper nickel alloy का make one solution of cupra nickel alloy, dissolve it in for cupronickel alloy you just add aqua regia. Aqua regia add करने के बाद aqua regia is what, mixture of HCl and HNO3. So you mix them in 3:1 quantity, concentrated HNO3 and HCl, heat it, you will get solution of copper nickel alloy. To that clear solution you add clear solution में pass H2S gas. ओके, H2S गैस पास करने के साथ क्या हो जाएगा, योर कॉपर will precipitate as black precipitate of copper sulfide. Okay, CuS, copper sulfide. Filter clear solution. In clear solution, now nickel will present in chloride form. So when you are adding dimethyl glyoxime, which is very good precipitating agent for nickel, so add alcoholic solution of dimethyl glyoxime, your nickel will precipitate as scarlet red colored precipitate of nickel DMG. So just find out how much amount of nickel DMG is there in complex. So 1 mole of nickel DMG corresponds to 1 mole of nickel. Equate that, जैसे practical के लिए theoretical yield निकालते हो. So by equating, whatever amount of nickel will come. So this is how gravimetry works. So आपको आपका कंपाउंड किसी प्रेसिपिटेट फॉर्म में लाना है, तो सल्फर के लिए क्या किया था, पहले सल्फर को ऑक्सीडाइज किया, कंपाउंड में से सेपरेट करके लिया, H2SO4 फॉर्म में लाया, और फिर बेरियम क्लोराइड डालने के बाद आपको बेरियम सल्फेट का प्रेसिपिटेट मिला. तो सल्फर हैज गॉन इनटू BaSO4 स्टेबल प्रेसिपिटेट फॉर्म. क्यूप्रोनिकल अलॉय में निकेल के लिए क्या यूज किया, पहले कॉपर को सेपरेट कर दिया, कॉपर का ब्लैक प्रेसिपिटेट सेपरेट कर दिया, फिर निकल के सॉल्यूशन में आपने ऐड कर दिया अल्कोहलिक सॉल्यूशन ऑफ DMG, डाइमिथाइल ग्लाइक्साइम, और फिर NiDMG स्कारलेट रेड कलर का प्रेसिपिटेट फॉर्म हो गया, वो सेपरेट करके लिया. नाउ फॉर एल्यूमिनियम, एल्यूमिनियम इज वेरी फेमस फॉर इट्स जिलेटिनियस प्रेसिपिटेट. एल्यूमिनियम के प्रेसिपिटेट बहुत सारे जिलेटिनियस फॉर्म में रहते हैं. सो the aluminum precipitates in their hydroxide form are gelatinous and they are converted into oxide forms. So whenever you take aqueous solution of aluminum salts, okay, aluminum salt का aqueous solution लिया, then they produce precipitate of hydrated oxide in presence of 1:1 ammonia. Okay, so to precipitate aluminum, take aluminum salt solution, heat it, and add ammonium chloride. Okay, ammonium salt, कोई भी ammonium salt, here ammonium chloride is added, and stir it constantly and add ammonia to maintain pH of solution. So when you will add ammonium chloride and ammonia solution, then you will get precipitate of aluminum hydroxide. So whenever you want hydrated form of aluminum precipitates, add to this aluminum salts ammonium salt, ammonium chloride and ammonia. Okay, so by using weight difference method you will find out weight of aluminum present in sample. So in application part we have seen 3 applications. सल्फर के लिए ऑक्सीडाइजिंग एजेंट कौन था, सल्फर के लिए ऑक्सीडाइजिंग एजेंट सल्फर के लिए ऑक्सीडाइजिंग एजेंट नाइट्रिक एसिड, वेरी गुड. एंड प्रेसिपिटेटिंग एजेंट सल्फर के लिए बेरियम क्लोराइड. वेरी गुड. एंड फॉर second nickel, precipitating agent DMG, dimethyl glyoxime. DMG is dimethyl glyoxime. Okay. And for aluminium, what is required is ammonium chloride.